Hi there, this is exercise 6c. We're going to look today at parallel and perpendicular lines, and of course you saw those a lot at Key Stage 2 when you was at primary school, but we're going to look now at, in particular, how to classify them properly using their gradients. And you saw a bit of this certainly at GCSE, well at least that was the idea, but we're going to do it properly. Obviously parallel lines, these two lines, if you look at these two lines, they're obviously parallel. You probably saw at GCSE very often we've put arrows or maybe even double arrows on to show they go the same way. And the great thing about two parallel lines is, if I don't know what the gradient is of this one, can we work it out? It doesn't go through any particular point, nor does this. If I took a point there and I did what you did at GCSE, you go across and then say how many squares it went up. Well, that I reckon it's a bit more than one up. That I reckon that I'm going to guess. I'm going to make a number up here. I'm going to say that's 1.2 up for every 2 squares we go across. So the gradient of this line is 1.2 divided by 2. Up divided by across, you might remember that, which is 0.6. And because this is parallel, this has also got to be 0.6. Don't need to work it out. So two parallel lines will have the same gradient. What's interesting is the perpendicular lines. So I'm just going to try to find what this gradient is. So this gradient seems to go, again it goes across 2, and again it looks to me, you know, very similar to the other one. It kind of, from there to there, is it a bit more? Let's say it's 1.2 again, it doesn't really matter. Now that's 1.2 divided by 2. The one thing I would say about this, when I'm finding the gradient of this, it's up divided by across again. But I've got to spot the fact that it's going down, and the fact that it's going down means it's negative. So really the gradient is minus 0.6 on this one. Now I also want to do this one. If I was to do that, what would this be? It's perpendicular, I know, but it goes one across there. Well, it doesn't actually, is it? It's just slightly shy of it. So I'm going to say that goes 0. What do you reckon? 0.8 across, maybe 0.9. It's only meant to be an approximation, this. And it's going from there, 1. I'm going to say it's a bit less. I'm going to say 1.9. I'm going to be sticking there. 0.9 for that, maybe. I don't know. Anyway, the gradient here is 1.9. It's definitely positive. Divided by that 0.9, and I've typically chosen numbers which aren't very nice, so I'll just do it on my calculator. 1.9 divided by 0.9. So when I do that, I get 2.1-ish. It's not an exact science. Now, you may recall this should be actually a relationship between these two things. There is a relationship which says if I know one gradient, I should be able to work out a perpendicular gradient as well. Obviously, parallel, as I've said, they're both the same. But what if? Now, I don't know how accurate these answers are. So let's go and look at the theory. Oh, by the way, just have a look at this. Now, it's just a quick starter. You just have to work out the gradients of all those lines. And it might, if you get a couple of seconds, just have a look as well. Are any of them parallel and perpendicular? And have a look at the answers you get. So I'm going to ask you to pause the video now, do those questions, say which the gradients of each line is, and then we'll talk about parallel and perpendicular. Okay, here you go. Here's the answers. Right, which ones are parallel and perpendicular? So the ones I'm interested in are like that one, 2. I didn't even know that one's no good. B and C. I think they're interesting. B and C. I think those two are perpendicular. Obviously the ones with the same answers, I haven't even got the same answers. I don't think, oh, these are interesting as well for similar reasons. H and I. These two are interesting, I think. These two are interesting. I don't think I've seen any which are parallel. No, I don't think any of them are. But certainly those two sets are interesting. I think they're perpendicular lines. And this is the basic reason why I think well, I know the answers for this. If you have two lines which are where the gradients M1 and M2, then if they're the same, as I've said, they're parallel. The interesting one is this. If M2 is minus 1 divided by M1, sometimes we call that the negative reciprocal, then they are said to be perpendicular. Sometimes people move this over and then you get m1 times by m2 and it is equal to -1. So we can also show this as well. This can be a better way of showing it because you get two answers. You can call one the negative reciprocal. You can say 1 times the other is -1. Now if I just go back a couple of steps to what we had right at the beginning, I had 2.1 and minus 0.6. So if I do 2.1 and times it by minus 0.6, now if I did this accurately, it should theoretically be exactly 1. But it doesn't look as if it will be exact. But as considering I was guessing my numbers, 2.1 times minus 0.6, and I get 1.26. So, well, minus 1.26. So you can see it's close. My God, clearly I didn't do my approximations overly accurately, or else it's meant to be exactly -1. Well, that's a reasonable look at that. So we're going to look at some questions based on that. So find the gradient of the line perpendicular to the line passing through these points. So first of all, it doesn't tell me the gradient, but luckily I've reminded you of the gradient here. So to find the gradient, you basically take one of the points. Doesn't matter which one. I'm going to pick this one, and this is going to be my x2, y2. Seems obvious. And this is my x1, y1. So I take one of my points, and as I say, I'm going to start at this one, and I do one y number minus the other. So I'm going to do the 5, take away the other one. That's a -4, so it'd be easy to think it's just 5 minus 4, but it's 5 minus a -4. And then I do the x's, but I stick them the same way around, -2 minus that 1. So I think I get 9 divided by -2 minus 1 is -3. So I think I get -3 when I do that division. Now if that's -3, that's my first gradient. And I want the line perpendicular to it. So my rule says m2 is 1 over m1, but with a minus in front of it. So it's equal to minus 1 over -3, which is a third. And that's the same trick. In fact, it might even be the same answers. Looking at -3 and a third, in the example we did, it was -3 and a third. So that's why I thought these two were perpendicular, because one is the negative reciprocal of the other. As it turned out, we then had an example which did the same thing. So m1 is -3, m2 is a third. So here's another question. I haven't got that last one right. It's nice to do this. This looks like a backward one. It's whenever you've got letters in it, you kind of think, it's a backward one. It's always a little bit harder. Find t given that the line joining D to C is perpendicular to the line of gradient 2. Alright, you just need to be a bit careful. The gradient isn't 2 for these 2 points. It's perpendicular to the line of gradient 2. So they're saying m equals 2, but that's really not the one I'm interested in. That's the first one. m2 then, I think, is, well, you turn it upside down and put a minus in front of it, so -1/2. This is what the gradient of these 2 points has to be, because it's perpendicular to the line of gradient 2. So if this is true, I've got y2 minus 1, so let's again, this is going to be x2, y2, and this one's the x1, y1. And my gradient of these 2 points, I'm going to write this as m is the y's first, remember, so I'm going to do t minus, or -3 again, we had one like that just now, and it's 1 minus a -1, so we've got a couple of minuses. And we know, of course, that this is equal to, we've already said that this equals -1/2. Okay, let's just tidy up this a bit. This is t minus, that's plus 3. 1 minus -1, that's 2. -1/2. I don't particularly like the divide by 2 here, so I'm going to move it onto the other side. T plus 3 equals what becomes the -1/2 has got to be times by that 2. If you do that on your calculator or in your head, you soon realize it's -1. 3 also moves over, becomes a minus again, -1, -3 more. I reckon t is -4. Got there eventually. T is -4, so there's your answer. So we in class are going to do some questions from exercise 6C, and that's the end of this lesson. So I hope that helps.